I want to talk today about limiting reagent problems, and we're going to start off by looking at making pizza. Now, it might not at first seem obvious why we're talking about making pizza, but I think you'll see what we're looking at and what we're talking about. First, I want to look at the ingredients we have for making our pizzas, and we've got 4 crusts, and it takes 1 crust to make each pizza. We've got 10 cups of cheese, and it takes 2 cups of cheese to make each pizza. And finally, we've got 15 ounces of tomato sauce, and it takes 5 ounces per pizza with regard to the tomato sauce. So how many pizzas can we make? Well, let's look at that. And we're going to look at this by doing dimensional analysis. And only a chemist would use dimensional analysis for making pizzas, but ignoring that fact for the moment, if we know we have 4 crusts and it takes 1 crust per pizza, or our ratio is 1 pizza per 1 crust, that means based on our crusts we can make 4 pizzas. If we look at our cheese now, we've got 10 cups of cheese, and again using dimensional analysis, it's 1 pizza per 2 cups of cheese. That means based on the cheese we can make 5 pizzas. And finally, if we look at the tomato sauce, and we know that it is 1 pizza for every 5 ounces of tomato sauce, that means that we can make 3 pizzas based on our tomato sauce. What this information tells us is that we're going to run out of tomato sauce before we run out of anything else. The tomato sauce is going to limit how many pizzas we can make. We're going to call that tomato sauce our limiting reagent. Everything else is said to be an excess or an excess reagent. So we're going to be able to make 3 pizzas. We might want to know how much cheese we're going to have left over. Well, if we're making 3 pizzas, I would just throw the extra cheese on the other pizzas. But anyway, if we're making 3 pizzas, and it takes 2 cups of cheese per pizza, that means we're going to use 6 cups of cheese. We started with 10 cups. If we use 6 cups, we're going to have 4 cups left over. And that's how we apply the idea of limiting reagent towards making pizza. Let's look at a more chemical example. So let me clear the screen. And we're going to look at making water from H2 and O2 gas, and we're going to start with 0.500 moles of H2 and 0.200 moles of O2. So let's see how much H2O we can make from each of those. If we look at the H2 first, 0.500 moles of H2. Our chemical equation tells us that the ratio is 2 moles of H2O per every 2 moles of H2. That means that we could make from this 0.500 moles of H2O. On the other hand, if we look at our O2, the chemical equation tells us that it's 2 moles of H2O per 1 mole of O2. Remember, we looked at this right here and said that based on our H2 we could make 0.500 moles of H2O. Based on the amount of O2 we have, we can only make 0.400 moles of H2O. So our O2 is going to run out first. It's going to be our limiting reagent. Now, if we want to know how much H2 we're going to have left over when we make this much H2O, we say, well, when we're making 0.400 moles of H2O, because that's all we can make, because the O2 runs out, the ratio is 2 moles of H2 per 2 moles of H2O. That means that there are going to be 0.400 moles of H2 used, and 0.100 moles of H2 are going to be left. So our O2 runs out. We're able to make 0.40 moles of H2O, and we end up with 0.100 moles of H2 left.